Today's lesson is going to be going over what we call complex fractions. As you go through this video, feel free to pause it and play it to give yourself time to write down the information that you need. And remember that this video will be available to you on Canvas, and it's on YouTube if you search for it. In order to talk about complex fractions, first I have to tell you exactly what a complex fraction is. A complex fraction is when you have fractions embedded in a larger fraction. And that sounds pretty vague as is. Just to make up an example to show you what this might look like, it could be, say, 1/4 divided by 2 over x. Okay, so here I have the big fraction, which is this big line, so this would be my numerator, and this is my denominator. But I also have these little fractions. So I have a 1/4 as a little fraction, the 2 over x is my little fraction. It could also have more operations in the top. So maybe it's 1 plus 3 over x over 2 minus 7 over x squared. That is also a complex fraction because you have one big fraction and then littler fractions within it. This is going to show up a lot in trig, so what you're learning today never ever goes away. What just changes when you get to trig is, say it looks like this: 2 plus 1 over secant of x cosine of x, or sorry, cosecant of x is technically right, over maybe 1 over sine of x, tangent of x. Okay, so it's going to look much more complicated, but the process that you will do is the same as what I'm going to teach you here today. So this is something that's going to be important for moving forward to upper level math if that's where you are going. So the first thing I'm going to do is give you some steps for simplifying a complex fraction. And then we're going to work through these on multiple different problems to make sure that you have an idea of what's going on. Okay, the first thing you're going to do when you are simplifying a complex fraction is you are going to find the common denominator for all your little fractions. So those are the ones that are embedded within the other ones. What that means for you is that you will need to factor each denominator of the little fractions. I would not at this point factor the numerator, I would only factor the denominators if that's possible. Once you've found the common denominator, you are going to get that common denominator for all your little fractions. So multiply by whatever each one is missing. And this is going to be something that makes more sense once we have time to go through it in this third step. But then you are going to multiply the top and the bottom of your big fraction by that common denominator, by your LCD. This is going to cancel all of your little fractions, and you will only have big fractions remaining. So this step will get rid of your little fractions and get rid of your your complex fraction. Lastly, you are going to simplify whatever is remaining. Okay, so you're going to combine like terms, you might have to factor, depends upon the specific problem, but you're going to simplify whatever's left over. Again, this is something that makes the most sense through practice, and so we're going to spend the rest of this video going over the types of problems that you're going to see. So go ahead and write this down. Remember, feel free to pause and play this video as necessary to go back over whatever you may need. So looking at this, the first thing I'm doing is I'm only looking at little fractions. So my little fractions are the a over 2 and the a squared over 4. Okay, this big fraction line, sometimes it helps to just make that bigger so that you know that's my big fraction, the whole thing is my big fraction, and my little fractions are just each of these. And what you need to do is you need to identify your least common denominator, and we're going to get that. So that step will kind of bleed together as you prepare and get better. So right now all I'm looking at is the 2 and the 4, and I need to find the least common denominator for 2 and 4. That is going to be 4. So then, much like your addition and subtraction problems, we're not going to get a common denominator. So my little fraction on bottom already has a 4, so I don't need to do anything to that. So this one I need to make it a 4, so I'm going to multiply by 2 on top and bottom of this little fraction. And what that's going to do for me, now I'm going to have 2a over 4 on top, and my big fraction line, and then an a squared over 4 on bottom. So my entire goal of that first step was to make these two numbers match, and they now do. Once you have a common denominator, we're going to switch to starting to only look at the big fraction. So I'm now looking at this whole thing and not just the little pieces. But I'm going to take this number and I'm going to multiply the top and bottom of the big fraction, so I write these bigger to help, especially at first, by 4. What's going to happen there, and I'm going to write this out long ways at first, but as you get going it will be easier to write it smaller. When you multiply the 4 on top through to this, again you multiply straight across, this 4 is technically over a 1, so this would be 8a over 4, and on bottom it would be 4a squared over 4. And then I would simplify this, 8 over 4 would be 2a. 4a squared over 4 would be just a squared. So again, 8a over 4 gives me the 2a, 4a squared over 4 gives me a squared. And what I want you to notice, if you compare this to this, really what happened is I just got the numerators because the 4's canceled in both spots. So you can also do it that way. Personally, I do not multiply it out and write this step. What I do is I know that these are going to just cancel because this is really 1/4 times 4, which is just the 1. Okay, so all you're going to have left is the numerators. And then I'm going to go ahead and simplify this fraction. You have a's on top and bottom, so it's going to be 2 over a. On these problems, I'm not going to make you give me excluded values because they're already kind of tricky, and I don't want to make it any more difficult. So this is where we will stop on these specific problems. Your entire goal is to get rid of the fraction within a fraction. So we started with these little fractions inside of the big one, and my final answer should not have any little fractions still existing. Your answer might be a fraction as an answer, but it should not have any smaller fractions embedded within it. You will simplify it completely like we did here. So we did not just stop once the little fractions were gone, we kept going until it was fully simplified. Okay, to start this one, again, I always draw the fraction line a little bit bigger to make the differentiation clearer, but we're going to factor our denominators that we can to be able to find our LCD. So this top one, the 18p, stays there. I can pull a 2 out though, and this is 4p minus 1 left inside. In the denominator, I can't factor that, so I'm just going to rewrite it. But what this did for me is it made it a little bit easier to find my LCD. They both have a common factor of 4p minus 1, and then my numerator has a 2 also. So my LCD needs both factors. It needs the 2 and it needs the 4p minus 1. Once I figure out what my LCD is, I need to make sure that both denominators are that. So I'm going to take this bottom fraction, and it needs the factor of 2. So my top one doesn't change, but my bottom one I multiply by 2, so this will be 8p squared all over 2 times 4p minus 1. The nice part with that, again, once the denominators match, I'm going to go through and cancel those out by multiplying the entire fraction, the big one, by my LCD, so the 2 times 4p minus 1 on top and on bottom. These will all cancel, and I end up with 18p over 8p squared. And then this fraction I'm going to try to simplify. So the 8 and 18, 2 goes into both, so it'll be 9 and 4. I have 1p on top and 2 on bottom, which will leave me with just 1 on bottom. And that is my final answer. Go ahead and try this one by yourselves, and then play the video when you're ready to hear an explanation of it. Okay, these two denominators, the c and the c squared, I cannot factor. So I'm just going to go straight to finding my LCD. My LCD in this case is c squared, because I can make this c be a c squared by multiplying it on top and bottom by a c. So I'm going to do that. It's going to be c times 7c plus 35 over c squared all over c plus 5 over c squared. And again, then we want to cancel out that. So now I switch to multiplying my big fraction by c squared over c squared. These will cancel. And I am left with c times 7c plus 35 over c plus 5. When you get to this point, you can distribute this c through if you want to, but if I'm going to be able to simplify this, I need to factor it completely. Okay, and here there's no like addition out here. We'll get to one like that later. So you can just keep factoring this as is. If I look at this top one, I can pull a 7 out. And then it becomes c plus 5 inside the parentheses over c plus 5 in the denominator. The c plus 5's cancel, and my answer is just 7c. Same thing, if you think you can try this one, go ahead and do that. But if you need to wait and just go into an explanation, that's fine as well. Okay, again, my first step is always just to factor the denominator. That's what I focus on. So on top, multiply to 8 and add to 6 is going to be 4 and 2. When you fully factor that, this will be b plus 4 times b plus 2 all over 1 over, and then when I factor the denominator, multiplying to negative 20, adding to negative 1 is negative 5 and positive 4. So b plus 4 times b minus 5. Last time I left in that common factor that I could have divided out. This time what I'm going to show you is what you would do if you do simplify one of those little fractions first. Be very careful because you can only simplify within your little fractions at this point. So like right now, I can try to simplify this numerator, and what I know is that those will cross out. So now that this is simplified with the b minus 2, or the b plus 2's that we canceled out, this would be 1 over b plus 4 all over 1 over b plus 4, b minus 5, and then we can find our LCD. Canceling it out made it a little bit easier for us because our LCD is just going to be the b plus 4 times b minus 5. We don't have to factor in that b plus 2. So in my numerator, I need to multiply this by b plus 5 over b plus 5. Oops, sorry, minus. And so on top, I'm going to have b minus 5 over b plus 4, b minus 5. On bottom, I didn't have to change it at all, so my fraction stayed the same. And then again, we're going to switch to our big fraction and multiply by our LCD, which is b plus 4, b minus 5 over b plus 4, b minus 5. All the denominators cancel, and I just end up with a final answer of b minus 5. Okay, again, especially since I'm gone, I'm just going to work out a bunch of examples in here. So feel free, if you are ready to just try this example, go ahead and do that. If you want to hear the explanation, just keep playing. If you're split, play it. And those of you who want to try it and just kind of ignore it and check when you're done. So here again, I focus on the denominators, and I'm going to factor each of these. So this becomes 3 times m plus 4. And then the numerator stays the same. The denominator is 9m times m plus 4. And so to find my LCD, I need to make them be the same. Well, I could turn a 3 into a 9, so the 9 is part of my LCD. I need this factor of an m, and they both have an m plus 4, so I need all of that. It's actually going to be this bottom denominator. To make the top one be that, I'm going to multiply by 3m, because it already has everything else. So So this is going to become 3m times 2m squared minus 2m minus 40 over 9m m plus 4 all over, this one gets a little big for a second, m cubed minus 5m squared, and then little fraction 9m times m plus 4. Switching to the big fraction, you're going to multiply the top and bottom by that LCD because it is going to cancel out your little denominators. And I'm going to be left with 3m times 2m squared minus 2m minus 40 over m cubed minus 5m squared. Once you get to this point, again, we go back to day one. So I'm going to try to factor this as much as I can so that I can simplify. From this, I can pull out a 2, and then it'll be m squared minus m minus 20. That 2 will multiply by the 3, so I'm really going to have a 6m in front of my problem. And then when you factor m squared minus m minus 20, you get m minus 5 times m plus 4. On the bottom, I have a GCF between these two of an m squared, and then we're left with m minus 5. And now I can start to simplify. Those m minus 5's cancel. This m crosses out, so I will have 6 times m plus 4 all over m. Okay. Now that we've had plenty of examples of just one fraction on top and bottom, I'm going to start looking at ones that have multiple. So here I have 2 fractions on top and only 1 on bottom. You could have as many in each spot as possible, but your process is still the same. So we're going to start by trying to find an LCD for all 3 denominators. And on my LCD in this case is 3x. So I need to make each denominator be a 3x, or each fraction have a denominator of 3x. So this fraction, I'm going to multiply by a 3. This one I will multiply by an x. And the bottom one will multiply by 3 as well. When we do that, you're going to have x squared over 3x minus 9 over 3x all over 3 times x minus 3 over 3x. And you can distribute this 3 through or just leave it like that. We won't really know till the next step what's going to be more helpful. Then we still multiply the top and the bottom of the big fraction by my LCD. And what we have to remember on top, specifically in this one, is this 3x will distribute. So it will multiply to both pieces. So it will actually cancel out all of the denominators because it's going to distribute through and cancel. So you will still have no denominators left. And we have x squared minus 9 over 3 times x minus 3. We want this factored. The bottom is currently fully factored, so that's fantastic. The top I can keep factoring as x minus 3, x plus 3, all over 3 times x minus 3. And then my x minus 3's cancel. And this is my final answer. Okay, so same idea with this one. If I start with my denominators, 4 is already factored, n minus 4 is fully factored, but this 4n minus 16 is really 4 times n minus 4 if I factor it. And the nice thing with that is that really becomes my LCD, because every denominator has those as factors. So to get a common denominator, I'm going to multiply the top by n minus 4 on top and bottom. I'll multiply this one by 4. And then everything will have the same denominator. So now I have 5 times n minus 4 over 4 n minus 4 all over 80 over 4 times n minus 4 minus 5 over 4 times n minus 4. And again, now we switch to the big fraction and multiply by that LCD to get rid of it. On top, those cancel. On bottom, just like before, this will distribute to both things, so it will cancel all of those. And what I now have is 5 times n minus 4 over 80 minus 5. Before we can simplify, if you ever have operations here, you're going to have to do them. So that's going to be a 75 minus 4. And then we're going to simplify. So you're going to simplify the 5 and the 75. The 5 goes into each over 15. Like we've been doing, feel free to try this one and see how it goes, and then listen to the video to hear the explanation. With this one, it's important to remember that these 1s are really over a 1. My LCD is going to be n, because that is what these two are, and when this is over a 1, that's what it's going to be. So I'm going to multiply both of my 1s by n over n. So this is going to be m over n minus n over n, all over m over n plus n over n. And again, now you switch to your big fraction and multiply by n over n, that LCD. It will distribute, so it will cancel everything. And we get m minus n over m plus n. While ugly, this doesn't simplify, so that is my final answer. Okay, we'll do one last on here to make sure that we are good to go. To start out, you're going to factor any denominator that you can, so specifically this 5a plus 15 really becomes 5 times a plus 3. Looking at all of my little fractions, I have an a plus 3 in both of them and a 5 over here, so my LCD will just be this 5 times a plus 3. And then I'm going to go through and make each fraction have that common denominator. So multiply the little ones by what they're missing. So my problem will be 5a squared over 5 times a plus 3 plus, this one didn't change, all over 5a over 5 times a plus 3 plus a plus 3 over 5 times a plus, a plus 3. Switching to the big fraction, we'll multiply by 5 times a plus 3 on top and bottom. It will cancel every denominator, and you will be left with 5a squared plus a squared over 5a plus a plus 3. It is crucial before you simplify that you combine anything together if there's addition and subtraction. So this is really 6a squared over 6a plus 3. And then go ahead and factor. That 6a plus 3, you can pull out a 3, and it will be 2a plus 1. 6 divided by 3 gives you a 2, so this is 2a squared over 2a plus 1. The rest cannot simplify, and so this is my final answer.